The integration between the internet computer, Bitcoin, and Ethereum is likely to catalyze enormous growth for all of these blockchains. Do you know why? First, let's recap the current state of Web3. Bitcoin is the cryptocurrency with the highest market cap. However, it does not support native smart contracts. Meanwhile, Ethereum, the largest smart contract network, is in need to scale. While Ethereum slowly works to scale, many new Layer 1 blockchains have launched trying to win the market. Now, most experts believe that the future of crypto is multi-chain. This means multiple blockchains coexist and work in a connected way. To achieve this desired interoperability, most chains resort to bridges. Like in the physical world, they work to connect two different ecosystems. In the cryptosphere, this translates to facilitating communication between blockchains through the transfer of information and assets. In practice, the method used is wrapping tokens that will be used in the other network. For example, if you ever used DeFi on Ethereum, you would not be able to trade Bitcoin, but only WBTC, which stands for Wrapped Bitcoin. WBTC is actually an Ethereum token created by an Ethereum smart contract that represents locked collateral of actual Bitcoin kept in the Bitcoin network. So when using Ethereum dApps, you do not trade actual Bitcoin, only a token that works as a claim on that locked Bitcoin. But I bet bridges remind you of something else. That is, hacks and exploits. In fact, Chainalysis estimates that they were the major sources of stolen crypto in 2022, with an amount reaching close to $2 billion. What usually happens in these hacks is that someone is able to have access to the locked crypto that acts as collateral in one of the networks. But luckily, the internet computer will not use bridges to integrate with other chains such as Bitcoin and Ethereum. For example, after the Bitcoin integration, the ICP smart contracts, called canisters, will be able to act like Bitcoin users, holding and transferring real Bitcoin on the original network. This will be possible for two reasons. The first is that the internet computer nodes will communicate with Bitcoin nodes to learn and keep the state of the Bitcoin network, like the blocks. The second is that the ICP canisters can request transactions to be digitally signed on the Bitcoin network by a group of nodes through an API. This group of nodes, or subnet, uses threshold cryptography to generate an ECDSA signature that is valid on the Bitcoin network. Let me explain what this means. ECDSA is the digital signature scheme used on Bitcoin and Ethereum to ensure that funds can only be spent by their rightful owner. Meanwhile, threshold cryptography consists of generating a joint digital signature by more nodes than the required threshold number, where each node holds a share of the private key. The end result is a safe and scalable way to sign transactions on the Bitcoin network, since the Bitcoin private keys are never stored in a single and accessible place. This is why you won't need to fear bridge hacks, because the Bitcoin transactions will happen on its original network and thus preserve the security of that blockchain. The same possibilities will apply to Ethereum and other networks that use this common ECDSA digital signature scheme. The Bitcoin integration is scheduled to happen by the end of 2022, and Ethereum integration should come around next year. This way, the internet computer will bring its highly scalable DeFi applications to these massive protocols that lack the capabilities of the ICP canisters. Don't forget to subscribe to our channel and follow us on Twitter, Instagram, and TikTok.